Hello everyone. Let's look at the daily Leetcode problem given on 12th July 1900. The earliest and latest rounds where players complete. Right. Before starting this problem, let us have a small motivational quote. We can grow and improve by observing and adapting to the good qualities of others. Everyone has something valuable to teach us. By appreciating and learning from their strengths, we become better versions of ourselves. This habit not only enriches our lives but also fosters respect and harmony in relationships. So let's stay open minded, embrace the good in people around us. Okay, with that being said, let us get started with this problem. So let us read this problem. This is an hard math problem. So I'll do my best to give you some thoughts and ideas, but I would encourage you to take up, uh, give me feedbacks or any other suggestions that you wish to, or any specific points that you feel like needs more explanation in the comment section. Right. So there is a tournament where n players are participating. The players are standing in a single row and are numbered from 1 to n based on their initial standing positions. Player 1 is the first player in the row and player 2 is the second player in the row. The tournament consists of multiple rounds starting from round number 1. In each round, the ith player from first row competes against the ith player of the end row, and winner advances to the next round. When the number of players is odd, the current for the current round, the player in the middle automatically advances to the next round. For example, if row consists of 1, 2, 4, 6, 7, player 1 competes with 7, 2 competes with 6, and 4 automatically advances to the next round. After each round is over, the winner is lined back up in the row based on the original ordering assigned to them, initially ascending order. After each round is over, the winners are lined back up in the row based on the original ordering assigned to them initially. The players numbered first player and second player are the best in the tournament. Okay, so these are the two inputs which uh, gives us the two best players in the tournament. They can win against any other player before they compete against each other. If any two other players compete against each other, either them might win and thus you may choose the outcome of this round. So we are free to choose the winners of any other players between other than these two, first and the second player, right? So given the integer n, first player and second player, return an integer array containing two values, the earliest possible round number and the latest possible round number in which these two players will compete against each other respectively. Okay, so let us understand this problem better through the examples given here. So understanding this problem is kind of very important after it would be tiresome after going through this lengthy description here. Uh, this is what I understand. So there are n players in the tournament, and we have been given with two players, the first player and the second player, who can defeat any player that come about. We need to return an array output such that uh, the positioning or the order between them leads to a competition where these two players compete against each other in a specific round, earliest round and the last round or the latest round is what the problem statement describes. So let's say we have given with 11 players. So in the second round, let's say we uh, have these set of players competing: 1, 2, 3, 4, 5, 6, 7, 8, 9, 11. Okay, so uh, 1, 2, 3, 4, 5, 10, 11. So in first round, these are the two players that compete, and similarly these two, and this would be the next one. So here what's happening, we have chosen 11 as the first, 11 as a winner. We are considering 11 as a winner between 1 and 2, and 2 being the uh, argument that we consider the first player and the second player to be the strongest. So we consider 2 as the winner, and between 3 and 9 we are considering 3 as the winner, 4 should be the winner, and out of 5 and 6 we are again free to choose. 5 and 7 we are free to choose, so we choose this one. So we are left with 2, 3, 4, 5, 6, and 11. So that's the value that we see here. And again, now with a round 2, uh, 2, 3, 4, 5, 6, and 11, so this becomes an even number value. So we are again free to compete with 2 and 11, so 2 will be the winner. 3 and 6 we are free to choose either 3 or 6 as the winner, and we would be left with 3 or 6, or we can choose any of them, and this would be the third round. So either one possible scenario which leads to the latest round. So third round is the closest round that uh, the first player and second player get to match up or compete. That's the first value that we see here. And another possibility, or the last round that gets uh, these two, so 2 and 4, to be matched up, is the fourth round. So these are the two values that we need to return, the number of rounds at which the players compete. So let's look at this example 2 here. So n is 5 and 1 and 5. So we know that 1 to 5 will be arranged in order. So it will always be this way. So it will be the first round and the first round only. The players number compete in the first round. There is no way to make them compete in any other round. Okay. So this is the output. Uh, uh, After looking at both the examples, uh, we might understand that it is important to, the deciding factor will be the way that we position, uh, or the other players in the tournament who gets positioned differently, and that is what will decide the earliest and the latest rounds with which the first and the second player that we are asked to check where they compete, or which round they compete, would be the other player's positioning will be the deciding factor. So, but with example 2, we see that, let's say, uh, the first player is 1 and the last player is at the last position, or the right side row, the first position, then they compete at the first spot, and that will be the min and the max. That will be the earliest and the latest rounds at which they compete. So, with that being said, so our approach should be, so our key idea here will be how we decide the other matchups of players in the tournament. So we know that the input value will be n number of players number of players, and first player and second player, first and second player, and our solution should be somewhat of a recursive method where recursive function where base case such as through the example file we knew that left is equals to right, or the L and R, L is the left position of first player and R is the right position of second player, right? So if this two is equal, then we can return 1 and 1, right? That is the current round is what they compete. The earliest and the latest round is 1 and 1. Let's say if for some reason we end up with left being greater than right, then we swap the value and proceed. Swap and proceed. Now, if we are required to design the so now our recursive conditions will start saying that, let's say we uh, our points will be like, say I and j compete, and we choose either I or j wins, either I or j wins, update the next state, update the next state, update the next state, keeping track in a so we shall keep track of the state through a results array, uh, state in an array, and new positions will be new positions will be k plus 1 by 2, because at each round the number of players get reduced, and therefore we can up we can update the position of the first and the right player by k plus 1 by 2 as well, right? So this will be a uh, one step higher, right? So it's like if the position is at 1 and he will stay at 1, let's say if the position of the right side player was at 5, then his position will be updated to 5 plus 1, or the third position, right? So the meaning here is, let's say we have 1, 2, 3, 4, 5 players, and we need to find the next, and we say these are the two strongest players. Then we say in the round 2, then we can, or let's consider 4 as the second strongest player. In round 2, first position will stay at 1 only, and 4 plus 1 by 2, this will be equal to uh, 3. That's the point, right? So where, let's say these two compete and these two compete and this one stays there, so we can say 1 and 4, uh 1 4 and 3, or 1 3 and 4, 1 3 and 4, this is the position, 1 3 and 4, and this is the third index and this is the first index. That's what we said here, right? the next state, with all these set, we also mark the new states with min and max rounds of outcomes or the rounds. So, so let's say if, okay, so just a second. With that explanation, I would quickly jump to the lead code editor instead of having to uh, write the structure of our code. Let me just start coding it up, and you guys can be proactive in letting me know if there needs to be any clarification on any specific code snippet or so through in the comment section. I want to keep the comment section going hard, right? Okay, let's code it. Okay, so let's start coding it up. As we discussed, there would be a DP recursive function which takes in left, right, and k the number of players at each round, and this will be a function. But before this, then we also would be having a memo map which stores the specific set of round values in a key format. So so this will be the start starting function call for this recursive dp function, and we will start implementing this dp function with certain base case, such as if left and right both are equal, then we simply return 1 comma 1, and if for some reason left value ends up greater than right value, then we swap those values, say right, left, and k, and we continue our dp call. Next, we create a specific key just to memorize the value so that we can use it in later rounds or for different players. Let's say we create a string as such where one and r, l, r, and k, right? And if at later rounds, if this memorization hash map has already been stored with this value, or this specific key is already been computed, then we can simply return the value. This would be a specific optimization that we are performing with this hash map, right? Okay, so we initialize the variables earliest and latest as infinity initially, since it wouldn't be computed at the start. Latest is equals to minus infinity, and we compute the half, that is math.floor k plus 1 by 2, right? Okay, so now we start a for loop which runs through for the left side players and another for loop for the right side players. So, and another for loop where the left side players might compete with the right side players. The j loop runs from left minus I plus 1, that is for the right pair of players, and this will be j less than right minus I, right, and j plus plus. Okay, that being said, we will say I plus j to say that these are the two players that are matching up in this round, and we also check if these are two valid set of players that can compete. Floor k by 2, or sum is greater than half. We simply continue to ignore this pair. And considering these two players are participating in the next consecutive round, we check for the earliest round that they compete with and the later. we get that from the TP array return value. These two positions of players being pushed to the next rounds with half as the k value being sent here, and we calculate the min value and the max value for each of them, right? Earliest and earliest comma sub. Similarly, for the latest, we do it this way and sublet. Okay, this will be max. Once we have this, we will answer earliest and the latest. And the latest, each point of time as we progress through the DP recursive function, and also the memorization value will be set with this key comma answer. Return answer. So that will be the final return of this. So with this TP, we get the earliest and the latest value of the first and second players that they compete in a specific round, the earliest and the latest rounds, and we are deciding them with the way that we take or compete these two, the other two players also in the round, right? So that's the whole point. So let's try running the solution. The time complexity of this solution would be uh, n cubed, as we have three recursive calls here. So let's see. Okay, this should be k. Small k. Okay. As you can see, the solution gets submitted. Hope you found this video helpful and the explanation was meaningful. Please do like and subscribe to my channel, and let me know in the comment section if you uh, want any further improvements on the explanation that is being done for this problem. Thank you.